has no mass is the answer. Now, I could ask a second question, which is, how come you know that? Okay, that's not simple. Why is it that things that have no mass must travel at the speed of light and obey the same laws as the speed of light, even if it is gravitational waves? How can you be so sure of that? Okay.
Thank you. So,
No,
can
I'm
I
still
ask?
asking you. Okay, okay, go on. So
Oh,
go on. Next
sorry.
question. Okay. Yes.
So, isn't it better to call it the speed of massless things instead of
Okay.
light?
Um, there is, in fact, I'm waiting for Prague to weigh in here. You're right. Uh, it isn't the speed of light. It is this. The speed is the speed of light. I do not think that we can measure the speed. Well, actually, it's not true. The speed of gravitational waves. Okay, so the speed of a gravitational wave was measured recently because there was a gravitational wave that we perceived, and we were able to correlate it with an optical event in the same region of space. And so that although this thing was happening a billion light years away, let's say, the events happened at the same time within a certain percentage of one another. Okay, so that we were actually able to confirm the speed of the gravitational wave was the speed of light, which we can measure very accurately. The speed of gravitational waves we cannot measure accurately, but the speed of light we can. So, but again, you're right. You're absolutely right. There's no reason to call it the speed of light. We could say the speed of gravity. Why not? Sure.
Yeah, exactly. And since I think we were the first to observe the speed of light at the speed of light, because that was Einstein at the age of 16. He imagined that light beam, and then that hype created. That's why we say it the speed of light. If we would have observed gravitational waves, we would say this speed of gravitational waves. And
Right.
also, Professor Laird, I think you asked a question. I was not able to get it. Did you ask this, that why massless particles only travel at the speed of light?
Yes.
Oh, okay, so I'm not sure about this. Okay, I'm a bit confused, but
Yep.
I think that
Well,
that's
I
my
know
answer.
I
Correct
know
me.
it's a hard
Yeah.
question. I know it's
Okay.
a
Okay.
hard question.
Then correct me if you know the answer. Massless
No, I don't.
particles, they're purely energy, right? Okay,
Right.
and they are completely stable. Like other particles, they're not stable, but massless particles are completely stable. They do not lose their energy, and they do not decay into other less massive particles, right? Since they have no mass, so all of the kinetic energy, it's all there, and they always travel to this at the speed of light, so they cannot be stopped, something like that, right?
Right. Right. Okay, but that's not quite the answer I'm looking for. I'm looking for an answer that's based upon uh, uh, something more in the realm of what if you were one of the scientists at CERN, uh, and you were one of those people, I think you would be more qualified to answer that question. Uh, it has a lot to do with quantum mechanics and atomic physics and it's there's I've read the answer to that question. I just don't remember it well enough to give it to you, Well, I told you I couldn't
Thank you.
say. Are you currently in Persia, or
Yes, I am.
you are?
Iran.
I know
Iran.
Iran,
Yeah, I'm from Iran.
right? But are you what city?
Tehran,
Tehran.
capital.
So you are the fifth
Yeah.
person in my room who currently lives in Tehran, and later on, uh, as the evening goes on, we will have somebody who spent 15 years who is Persian, uh, and uh, and he is in fact now living in Germany, but so if we count that, then we have six people, six Iranians in this room at
Iran.
any. And so
I
I'm
guess
always
I
thrilled.
guess I know. I guess I know one of them, Saeed.
Yes, yes, to him. Yes, Ken.
Said is my friend. One of
He
them is
is.
Said. Thank you. Thank you.
Oh, thank you. Oh, really?
Pardon
That's
me?
great to know. That's wonderful. So, so,
Okay.
so,
I appreciate. Thank you for giving me the opportunity to ask my question. Thank you so much. I enjoyed it.
do you have another question?
No, thanks.
Okay, good. Okay,
No,
good.
thanks. Thank
Thanks.
you.
Well,
Thank you.
Hi,
I
Laird.
appreciate your time. Thank
good.
Uh, Hi, Laird. I
So,
just wanted to add on that Shahzad question on the gravitational wave, and I'll go back to the
yes,
audience. Is it fine?
yes, please. No, but
Yeah.
can you add why gravitational waves? Why do they travel at the speed of light? Uh, and why do massless things travel at the speed of light and only at the speed of light? Is the question.
No, I had a question on top of
Okay,
hers. Yeah.
okay, so you have to. Then you should wait. Okay.
Okay, fine. Fine.
Good. Okay, thanks. Okay, Diana, you
Hi.
look like you're at the bottom of a well.
What'd you say? I'm sorry.
You look like you're at the bottom of a well.
That's where I am.
Are you in the, well, so are we all. We're in the
I
big,
can see
deep
the light though. You see the light?
yeah. Well, we are all at the bottom of a gravitational well. So I think we're all in there with you.
Interesting.
Uh-huh.
So I have a weird question. It's intentionally broad. Do
Yeah.
you believe in time travel?
No, I do not. I do not believe in time travel because I met the man who proved it wrong. Okay. Uh, and so he was one of the funniest scientists ever, uh, and uh, he was uh, he worked on the Manhattan Project. His name is Richard Feynman, and he he uh, uh, and he wrote a book or biography about him. It's called "Surely You Must Be Joking, Dr. Feynman." I think is the name of the book. Uh, and yet he was one of the biggest jokers, scientist jokers of all time. And one of the things that he joked about, for example, is he when he was working on the Manhattan Project to develop the atomic bomb, he uh, he thought that scientists were idiots, so he went around and broke into their safes and left little notes which said, "I've seen it." So he was well known at the end of the project as being a prankster. Uh, later on, later on, uh, uh, he decided to test to see whether time travel was possible, and so what he did is he invited time travelers from the future to come to his room. Uh, he set up a party. Drinks were served, champagne, hors d'oeuvres, food, all sorts of things. But he didn't announce the party until after the party was over, uh, figuring that if any time travelers had heard about the party, they could have come to the party after it had been announced. But so they would have learned about it in the future and come back to the past. Nobody appeared in his room, so he then offered that as proof that time travel doesn't exist, and I accept that proof.
Thank you. I'm definitely gonna look into his book. I appreciate it. And I have one more question if that's okay. Going
Sure,
off
sure.
the woman.
Absurd
Oh,
questions are good.
thank you. Going off the woman, I can't pronounce her name. Could you explain what causes a gravitational wave? Like in
Sure.
layman's terms? Thank you.
Um, well, if you jump up and down, okay, you cause a gravitational wave. You try to climb out of that gravitational hole that you're living in right there. Will cause a gravitational wave. The wave will be very, very uh, 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 unable to be detected by any detector anywhere in the universe because it's very low intensity. So what you need, gravity uh, produces very weak signals. So you need very big things. You need to shake very big things in order to make the signal that you can observe. So, and the signal that you observe uh, is is mile-long detectors that vibrate less than a millionth of the diameter of the proton. That's how little the thing vibrates. Okay, and what do you need to make something vibrate less than the diameter of a proton? You need two black holes colliding, or two neutron stars colliding, and combining into one entity. The combination of those things spiraling into one another in the last split second, it causes the gravitational wave that we measure. The process that took millions of years for those two things to finally spiral into one another is too weak for us to measure. But the last few seconds of that process is something we can measure. And so we've measured it now, that sort of thing, now quite a number of times. And originally just once, then twice, and now I think we're up to 10 or 20 of these measurements, or maybe even more. So that's what does it. Now, that may not be enough of the answer, but that is the answer. An answer. Are you there?
Hi, thank you. That was a really helpful explanation for someone who isn't, I'm not the most knowledgeable, so that helped a lot. Thank you so much.
Now, do you know what a neutron star is?
A neutron star? I do not.
Because that also makes gravitational waves. So you know what a black hole, you know what that is, right? Everybody does, right?
Yeah, that's how I was led here tonight. I was on this documentary on Amazon, and it's like, or I'm sorry, yeah, Amazon on black holes. And so I got on Clubhouse and here I am.
How did you find me? I'm just curious. You came here, and you were looking for astronomy, and you found this room.
So I typed in, you know what? I actually typed in black hole.
Uh-huh.
And then interestingly enough, I think 4 down, it was like astrophysics club, and somehow that brought me to you guys.
Okay, got it. Right.
Yeah.
Okay. So just because see the fun thing is that for me in this room is telling somebody. See, this wouldn't be interesting to me if you had heard about a neutron star and you wanted me to tell you about a neutron star. But since you'd never heard of it, you see, that's fun. Okay. I'm gonna try to blow your mind. Okay, ready?
I'm ready.
Okay. Uh, so there is a process uh, that can take a star the size of our sun, and through this process, which I will get to later, shrink it without losing any mass, much mass. Shrink it down to something the size of Manhattan Island. Something city sized, not Earth sized, mind you, but city sized. Turn the entire sun into, compress it into something that is that dense. That's a neutron star. It's no longer made of atoms, it's made of only neutrons. The atoms have disappeared. The electrons have been forced into the protons, and everything becomes a neutron. And the universe is filled with them. And when two of those things crash into one another, you get a gravitational wave that we can measure. So, have you ever heard of a neutron star now?
Yes, I have.
What do you think?
I think I need to understand it further, but
Yeah, I didn't tell you what the process.
somehow it makes sense, if that makes sense. It's
Well,
like foreignly makes sense.
I left room for you to ask a question, though. Okay, and the question that you neglected to ask was, how do you turn a sun into a neutron star? And the answer to that question is you blow it up. And how do you blow it up?
Mhm.
You start with something that's bigger than the sun, for one thing, and because the sun itself will never turn itself into a neutron star, it will only become something the size of the Earth, not the size of Manhattan Island, uh, which is part of New York City, in case you didn't know. Uh, so when a star blows up and becomes a supernova, uh, the core of the star collapses in on itself, not being able to be held up by anything anymore, because because the star just gives up the ghost and says, I give up, I can't do this anymore, here I go, I'm just going to fall in on myself. But eventually it gets stopped, and it gets stopped by the fact that it becomes a neutron star. But it doesn't stop before it pretty much it squeezes to death. Uh, and those things will sit around the universe forever, for trillions of years, just spinning around and around and around. We see them all over the universe. Well, actually, all over the galaxy. We can't see them in the universe, but we see them everywhere. You look up in the sky, there's neutron stars everywhere you look, not just stars. So there's your answer to the unasked question. Okay, I hope that Clubhouse doesn't work when I can't see people's expressions. But in any case, thank you very much.
Thank you so much. I want to know about 42, but I don't want to take too many questions. So thanks for your time.
I'll just tell you about 42. Nobody asks what 42 is in this room.
Okay, I had to ask because my initials are DB. So D is the fourth letter in the alphabet and B is the second. And so I've always been obsessed with 42. And in high school, we read or we watched The Hitchhiker's Guide. And I'm sitting there and like 42 is haunting me. I keep seeing it on the clock. And then they're like, what's the meaning of life? And they say 42. And I'm sitting there feeling like I'm like in a video game.
That's it. That's
Yeah.
it.
So
That's
42 has been haunting me my whole life. And I
Yes.
have to understand why. Okay, go.
Well, no, the thing is, it's a joke. It's a joke. It's nothing more than a joke. It's a very, it's one of my favorite jokes. But you do realize it's a joke, right?
I do. I do.
Right. I have written a book, a story. I was asked, no, I volunteered to write a story for a book that is about, it is in honor of Douglas Adams, and it is I think probably the name of the book is 42. It's being anthologized as we speak. I submitted it a work of my own. It had to have a title that was 42 letters long, and it had to be 42 words exactly, no more, no less than that. And I'm very proud of this book, of this submission of mine, and I'm going to find it in 2 seconds if I can, and read it to you because it's only 42 words long. So hold on, no, that's not the right place to look. 42, 42, search.
It's on my phone right now.
Could you read it to me?
Sure.
Okay. Read.
I think you're muted.
Yeah. Dara, do you have it? Would you read it?
Technology, this is the title. Technology on That Eternally Cloudy Planet by Laird Whitehill. In the infinite universe, there is an Earth-like planet that is so cloudy that they never saw their sun. One day, they built a rocket ship and flew above the clouds and saw stars for the first time, and that changed everything.
So, Diana, that is my homage to 42.
Mind blown.
Good. Finally, I blew your mind. Good. Moving on. Moving on. Thank you, Diana. That's wonderful. AK.
Astrophysicist, yes. Shakespeare.
Hi, sir. Thank you for this opportunity.
Yes.
I came in with one question, but after listening others, I got two questions. My first
Okay.
question is, what is gravity lens and how can it have its effect on massless object like photon? How can a gravity lens bend photon when it don't have any mass? That's my first
Oh,
question.
okay. And do you want to name the second question, or you
Yeah,
want
sure.
to? What's the
My
second question?
second question is, if the Big Bang is true, then every object should move away from each other. Then how come
Right.
galaxies collide each other and galaxy clusters collide each other? That's my
Good.
second
Okay.
question.
Good question. So okay. So the first one uh, is fun. Uh, uh, you want to know why gravitational lenses work when when light doesn't have any mass, right?
Correct.
Okay. So uh, you get the Einstein Award of the night. Okay. Uh, because Einstein uh, thought about this a little bit, and he said, "I have the answer." In fact, if, he uh, you're actually asking for me to explain general relativity to you. You do realize that?
No, I have no idea.
Yeah.
Sorry if it's
So
complicated.
no, it isn't that complicated. Okay,
Okay,
it isn't that
thanks.
complicated. Uh,
Okay.
uh, uh, the only thing you have to imagine is that uh, is that gravity is in it's not any different from something that's accelerating. If you're falling down, okay, uh, you're accelerating. Uh, you don't know if you are falling down due to gravity or whether you're just floating out in outer space a gazillion miles away from anything gravitational. You don't. It doesn't feel any different to you. So if
Without
you're falling down in a
sorry.
gravitational field or you're not, and you're just floating, it feels the same. That's what Einstein said. Okay. So
Got it.
AK, uh, will you accept what Einstein hypothesized, that those two phenomena are indistinguishable?
Yeah, I get it. I get it now. It is like without a relevance point, you can't tell whether you're moving or not. It's like falling in the
Right,
darkness
right.
without
But
knowing any reference point. Yeah,
and you're inside this cube, and you can't see out. You can't tell whether you're falling or whether you're not falling. It's indistinguishable. But if you are falling, okay, if you are, I'm going to sort of shortcut this answer. If you are falling, then the light that enters one side of the room that you're in will exit not in a straight line compared to where you think it should have gone. In other words, the light should go straight, right? But it
that's right.
doesn't. It
Yeah,
bends, right? Because you're falling. So Einstein said, well, the reason it bends is because gravity did it. That is the shortest explanation of general relativity I've ever been able to come up with.
okay. Thank you, Professor.
Okay. You can call me Laird. It's not Professor, it's just Laird. Uh, the second thing, so, and by the way, if there's anybody, do we have a scientist in the room? Swapnil. No, he's not. Okay. No, it's Prayag. You're here in the room. Uh, uh, what did you think of my 30-second explanation of general relativity?
It was great. It was great. Explaining such things, it's hard. I'm a science communicator, so yeah, it was great.
Okay, thank you. Because one of the reasons I do this room is because I look for ways to explaining things I've explained before differently. AK, thank you for the question. Uh, the answer to your second question, what? Uh, Visnel,
Yes.
what did you say?
Yeah, I'm following. My second question is, if
Oh,
Big Bang
I know
is
I know
real,
your second question. If the Big Bang
Okay.
is true, okay? I love the part where you began with if the Big Bang is true. Can I just ask you this? Uh, are you not certain the Big Bang is true? Or you think you've been told stories?
No, I believe in Big Bang, but
Okay.
this phenomenon confuses me.
Okay, it's very simple. Okay, the reason that you're confused is because you are not using you're not you're comparing things at different distance scales. Okay, so there is a thing that you should look up. It's a two-word phrase called proper motion. Proper motion, and what you're talking about is the proper motion of galaxies. It doesn't mean proper doesn't not mean good. Uh, I don't know why the word proper motion at all, but that is the phrase, and what it means is that when you talk about a phenomenon, like for example, uh, the uh, uh, the stars in the sky. If you look up in the stars in the sky, they don't move, right? They don't move, but some of them do. Uh, but the ancients didn't see those stars move. They did not notice the proper motion, but the ones nearby do move. Why do they move? Because they're closer. And so, because they're closer, you can see the angle that they move through is much more observable than than ones far away, which do not exhibit the proper motion because they're too far to be for their parallax to be seen. Okay, so what you're talking about is things that are close to each other or to us. In the case of Andromeda, it's close to us. So we're talking about Andromeda is 2.5 million light years. Okay, and things in this universe are 2.5 billion light years. That's a factor of 1,000, and it's even more than that. It's more like a factor of 2,000. Okay, so you're comparing a fact. So you're the problem with what you're seeing is factors of about 1,000. So at this time at a scale, at a very small scale, things do whatever they want. They go this way and that. But when you expand your field of view by 1,000-fold, the proper motion of those objects cease to be interesting, and they get drowned out by the systematic motion of the universe. That is the right answer to your question. Do you need more?
Um, that that wants me to ask you another question.
Good. Go.
When galaxies move further and further away, there's something called redshift.
Yes.
So that means if you are standing, let's just imagine if you are one galaxy and watching another galaxy approaching you, will it be a blue shift to you?
Yes. But only nearby. Okay. Only nearby, because the redshift of the expansion of the universe overwhelms the blue shift that might be occur that might be important if it was nearby. So Andromeda is a blue shifted towards us, and certain nearby galaxies are blue shifted towards us. But the further and further you go, the less possible that is, because the expansion of the universe rules. I don't know how far you have to go before the universe itself takes over. I would guess that at the distance of about 500 million light years, the expansion of the universe is the only important factor. There's no more blue shifts.
Right.
That's my guess.
Um, so in all of this, there is no work of dark matter in this, is it? Is it
No,
just normal?
the dark matter conversation has nothing to do with this. Dark matter
Okay.
doesn't have anything to do with the expansion of the universe. I'm not going to. I'm going to subtract that answer. Of course it
Okay.
does, but not in the sense of the question you asked.
Okay, thank you, Laird. And that's all from me now. Thank you.
Okay, good, 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 good. And by the way, where are you physically in the world?
Uh, I'm in New Zealand, Auckland.
Ah, okay, very cool. What time is it there in New Zealand?
It's 4:15 p.m.
4:15 p.m. Wow,
Yeah, on the
wow.
24th, Thursday.
You know, when Clubhouse has this picture of different people, different races, different sexes, different. The fact this Clubhouse is literally for every person on Earth. Uh, uh, is it can be in this room tonight, and sometimes they all are. You know, they're from they're there's almost no place on Earth that they're not uh, at a given evening. It's amazing. I'm just flabbergasted. Thank you for being here.
Thank you, sir. Thank you for
Uh,
the opportunity.
yeah, please come again. Prayag, now you are an astrophysicist. You're here. You can be here to answer, or you can actually ask questions, because who knows? Maybe you want to know something that I know, and you don't.
Yeah, yes, there was this one thing. The question that you asked earlier, why masters think travel at the speed of light. So if you have that article or you come across it, can you just send it to me?
Oh, okay.
Mm.
Let me see. Let me see your profile. Let me see if it's in there.
Yeah, I'll
Uh,
put up my email there right now.
you know what you should do, because I'm an old man. Send me an email, okay?
Sure, sure.
And that way I'll put it in my box, and I can do that. That's easier
Yeah,
than me trying to
yeah.
remember. And
Okay.
and in your
So,
email, say that, okay? Say
yeah,
that, and
absolutely,
thank you.
absolutely.
It's
Thank you.
so much easier. I do everything electronically, but I don't take notes. I don't own a pencil or a pen. So yeah. So thanks. Uh,
Yeah,
so Vish,
sure.
so Vishnu, uh, if Prayag is finished, Vishnu, uh, cosmology, space, uh, those are your profile. You're here to ask, do what? Why are you here tonight? Are you there? Sometimes people,
Sir,
there you are.
how
There
do
you are.
string theory make up universe?
Uh, uh, Vishnu, Vishnu, you're a newbie to Spread House, to Clubhouse. I have to say that when anybody asks me anything about string theory, I usually say I don't know, and I didn't understand your question, but the chances of me after I understand your question, the chances of me being able to give you an answer are kind of slim. Do you want to try that question again? But I doubt if I can answer it. Go.
No, sir. Thank you, sir.
Thank you. Okay. Uh, so, because string theory is okay, I'm just not going to go there. Uh, just let me say, I can't. I choose not to try to answer it. Swapnil, have you been here before? No, I don't think so.
Factorial ways. Yes, sir. Hello.
Uh, but so what is your reason for being in this room tonight?
Oh, hi. Sorry. Can you hear me?
Yes, I can.
Yeah. Hey everyone, and thank you so much, Laird, for inviting me on stage. Um my question is, I'm not sure if it's related to your field because I'm just, as an enthusiast, I'm learning from smart people. My question is, given this current ecosystem of private companies dabbling into space, uh, do you see that in the coming, I don't know, decade or so, that these companies or even government entities such as NASA would be venturing into mining for minerals, or in general like collecting some more data,
Sure, why not?
yeah, which can be like useful, and like I'm just trying to figure out like is there a space for like is there an aspect for people to just get access to that data and I don't know, visualize it, because I come from a gaming background, so I guess you can see that what I'm really trying to get to. And that can this be visualized in a form of a game format, like, just pick up any random game? So yeah, I'm so sorry, but my question is a little bit, discombobulated, but yeah.
No, I understand, and it's fine. It's great, in fact. Uh, um, um, the name of the website I'm trying to think of the name of the website you want to go to. Um, um, uh, my brain is frazzled. I'll be thinking about it for a while. Uh, while I try to think of it, it is a website that classifies uh, asteroids according to the cost the cost, how much it would cost in present day dollars to mine it, and the profit therefrom. So literally, it tells you which, it literally can be sorted by the most profitable asteroid in one hand, and on the other hand can be sorted by the easiest to mine on the other hand. And so there's a list of, I don't know, a few hundred, if not a few thousand asteroids based upon their value. So this is a serious conversation out there.
What they
And if anybody in the room happens to know this, Tony, do you happen to know the name of this place, this website, uh, or does anybody else in the room have? Or
I
Dara, do you know?
have the website.
Oh, yeah, what's the name of of course, Dara, you know it. What's the name of it?
I'm still looking for it. I have saved it somewhere. I'll let you.
Yeah.
Yeah, you've given it several times, Laird. I'm looking it up also. But you
Okay.
have given it recently,
Right.
2 weeks ago.
Right. So therefore, there's absolute proof that my memory is poor.
No, we're all in the same boat there.
Yeah. Uh, so so there really is. I mean, in Clubhouse, there's a lot of conversation about this. Do you know that there's a lot of conversation about mining asteroids in Clubhouse?
Yeah, I mean, I'm not super familiar with it, but I know that such conversations are going on, so I just keep
Yeah.
on hopping as much as I can.
Well, what do you want to know about I mean, the question was fairly vague. What are you trying to do with it? What's your idea?
My idea is something which is related to data visualization, because yeah, what I really see is, I don't know if you're familiar, but what current industry standards in Industry 4.0 that people are heading towards, visualizing data by collecting drone surveys and satellite data, at least on like for the major mines located in Canada and other major countries. And so they're basically doing is just they're kind of making a game, but they just rip out all the entertaining part, and they just keep it uh, uh, they just keep like useful features, what they really need. And I'm just really trying to assess that. So like, do you see like, is there an opportunity for something similar in space?
Tell me about the data mining 4.0. Is that what you said?
Yeah.
I don't know about data mining 4.0. Tell me about it.
Oh, well, well, it's called data visualization for Industry 4.0. I mean, you know that.
Oh, okay. Data visualization. That but I didn't. I'm dimly aware of data visualization. I have lots of data visualization things that I've looked at. I've looked at all sorts of wonderful stuff. They have great stuff these days. I didn't realize it's an industry, if you will, almost. Uh, but but so what is the idea with data visualization? To show what, to learn what or about things. It's sort of, if you will, a four-dimensional way of looking at data. So
Yeah.
you can see many things at the same time.
Yeah, I mean, so what people are currently doing is, like, for an instance, a lifespan of a mine is for ranges from 200 years to 300 years or so. So what they're really doing that over the course of the time, they're really trying to predict that where the ore is located, and then they are, and that's how mostly open pit mining are done.
I see. Okay,
Right?
I understand
So
that.
yes, so what people are doing now is, as I mentioned earlier, that they're collecting data from satellites and drone surveys to really triangulate position, position or location. My bad. To for potential drilling holes, so which they can keep on continuing in the future. So and they're trying to combine all of that these data points into a 3D sort of a gamey software, and where people can interact with, and it can just ease up communication among different members or departments which are engaged in mining. And so yeah, that's what essentially data visualization means. It's just like
Okay,
you're visualizing data. So I was just really curious that what if this thing can be headed towards space, and
It's
sure. So look, here's the thing. Uh, uh, we don't go there with drones, but we go there with spectrometers. We go there and we look at the surface of asteroids with spectrometers, and we measure the what we think to be uh, uh, we measure the spectrum, and then the spectrum tells us what we think that the asteroid may be made of, uh, and we get a sense of what the density of the thing might be, and given the density, we might be able to predict what the elements that it contains might be. Uh, so less dense, less valuable; more dense, more valuable. If you're talking about mining heavy rare earths and gold and palladium and stuff like that. So those asteroids they don't have a lot of data points, but uh, we've got these missions coming back from these asteroids with some data, and this data is going to be able to help us get what. And I'm sure you know what this word is. It's a great word. It's called ground truth, right? Uh, and these things will give you ground truth for a couple of asteroids, and that'll give us a lot more data because now the spectrum will mean a lot more. So they'll be able to separate these asteroids into further and further categories of more and less valuable. You so that should
okay.
be interesting.
Yeah, I mean, I do have a follow up. I hope I don't take that much time.
Go ahead.
Yeah, yeah. So, I mean, this data visualization doesn't has to be related with mining only. I mean, I just used mining because that's what people are
Right.
doing, and just gave me a base. But in broader perspective, like, do you see other applications which can be useful or kind of like needed, but with which they don't sort of exist? Or like might be needed in the coming future, from it could be from educational perspective or something which is related to your field, that you would think that okay, so if we would have something which would give us like in a visualized format, that would be easier to make our life easier or make our jobs easier, something in
It,
that
it, it's a
kind
good question, but I think that the answer uh, requires more thinking than I can spend right now. Uh,
of.
in other words, I don't know the answer, but I can maybe think about it. Uh, where Here's the thing: when you're when I attend astronomy lectures, in which they are presenting a large amount of data, the
Hmm.
problem is that the graphs that they present are usually two-dimensional plus a
Yeah.
third and maybe a fourth dimension, and sometimes they add time for an additional dimension. And the thing is, a hologram would make a nice extra dimension. Uh, so the thing is, there's a lot of patterns that need to be recognized in order to be able to make new discoveries. And the more data that you can visualize at any given time, the more you can begin to see what really is going on and see the forest for the trees. You know, so that's my bottom line answer. It's saying that I won't go any further with that. Okay.
So I see.
Yeah.
Yeah, I mean, thank you so much for your time.
But I'd like to think about it some more. Uh,
Yeah, yeah,
because
I'll keep on dropping into your future sessions.
I do have a in my astronomy lectures I do talk about visualization is one of my topics, and it's and the idea is how to visualize the universe. And so I'm constantly trying to visualize the universe. And so I have I've delivered a few lectures in my uh, um, YouTube videos on visualization of universe. Problem is with those lectures is they generally didn't turn out too well because the visualizations didn't come up well on the screen. But my but there is reference to my to a website that I produced, which gives you access to all the visualization software that I reference in my lecture. So if you're interested in that, you might be able to find it.
Yeah,
Look,
for sure.
look through my YouTube videos and see if you can find some reference to that. They would be referenced in the beginning of the video where I would explain what I'm about to talk about.
Yeah, and also, may I also have the link which you were talking about a little earlier, which reveals the cost analysis of mining from asteroids?
Jared, did you find it yet?
Yes, it's called strank.com. ASTERANK. It's really cool.
Thank
Astra
you.
Astra Rank, one R. Astra Rank, one R.
Thank
And
you.
it'll blow your mind.
Okay. Yeah, I mean, it already blew my mind when you described it. Thank you.
In fact, if you have time, just sometime before the room ends, just come back for a minute and just say what you think about that that website if you've seen it. Okay.
Right. Yeah, I also have something which you can also refer to. I don't know if you are aware of it. There's a studio called, I mean, game studio called Blackbird Interactive. It's also based in Vancouver, and they did a visualization for JPL, Jet Proportional Laboratory, and their visualization was done for Mars. So I don't know if maybe for
What's it called? Black Body Interactive.
oh no Blackbird Studios. Blackbird Studios. Sorry,
Black
Blackbird Interactive. Sorry, my bad. Blackbird Interactive.
Blackbird Interactive.
Yeah, that's the name of the game studio, and they partnered up with JPL, and it's for free. Anybody can just go online and just download it for free, and it's a pretty cool visualization in my opinion.
Okay.
And
Tony, would you think about that for me and tell me at the end of the room? Blackbird Interactive. I'm going to forget it. Can you do that for me? Blackbird Interactive. I don't have a pen. I will write it at the end of the room. Okay. Thank you, Ms. Swapnil.
no problem. Thank you.
I now made Tony into my scribe. Hope you don't mind, Tony. Um, so the view profile. Joe. Yes.
Hi, Laird.
Hi.
So my question was just a follow up around what Sharzad has asked around the gravitational wave. So then during this time that I had to retrospect about the question, I lost sanity of it, and I figured out that I don't even understand how waves properly travel. So I'll just anyway put it out. What the thought I had is like was light is
Say again.
um, something that travels through space electro. Sorry.
No, go on, please.
Yeah, so if you think about it, it's the electromagnetic field that's actually traveling through the speed of light. But gravitational waves seem to me like it's the entire fabric of space-time itself that is traveling, right? So why should that uh, like be traveling exactly at the same speed?
Well, you do know that we didn't answer the question, right? We do know that gravitate. Well, okay, gravity waves would be the result of gravitons, if you will, and gravitons are like photons, right? And photons do not have mass, and gravitons do not have mass. And you know that photons both behave like a particle and a wave, and you know that gravitons would therefore also behave like a particle and a wave. So we're by analogy here. Uh, if you're happy with photons moving at the speed of light as a wave and also as a particle, then you should not have any problem with gravitons moving at the speed of light as a particle and a wave. This, of course, does not answer your question. It just puts it in the perspective of a new perspective. That's all.
Yeah. So, as a follow up of that, you did mention in between that gravitational waves can be formed if I jump. Right,
Yes.
but is that actually true? Because I'm dissipating some form of energy by the mere act of jumping, right? So does that mean any particle that moves, anything that has mass, which has an influence on the gravity, is actually dissipating some kind of energy through the notion of motion?
Give that man a cigar. Yes. Yes, that is true. The amount of energy is ridiculously minuscule. But yes, energy is being dissipated when you jump up and down. Gravity, you have literally removed some mass from the Earth because you have changed some of the gravitational energy of the Earth Joule system into a gravitational wave, and the Earth has lost a little bit of its energy as a result. Yes, it is true.
Okay,
We are we are
that's
le-
a yeah,
we
that's a
have
new one
less.
for me too. Thanks a
Yeah,
lot.
I mean, this is just a logical conclusion. You know what I mean? It's absurd, but it's true. Has to be. Where else would the gravitational energy come from if it didn't come from the Earth Joule system? You know, so you and the Earth must have lost something in the process. You know, energy is conserved. Okay, is that it? Is that your question? Is it, Joel?
Yeah, that's it. Thanks. Yeah.
Good. Thanks.
So may I
Uh,
speak?
yes, please. Setu.
So what is the fourth dimension if it's not time?
What is the fourth dimension if it's not time? Aside
Yes.
from this string theory business, okay, uh, it's time. There, I don't, leaving out the question of more complicated stories. Uh, I'm not comfortable with the idea of a fifth dimension. Okay. On the other hand, it's really hard to discuss multiverses or parallel universes or those sorts of things without at least talking about it a little bit. But I uh, I've never read anything which talked about really a fifth dimension. So let's just stop with four. Four dimensions, including time, and there's a lot more to talk about than I can really talk about in this room because I'm not a cosmologist. I'm not a person who is an atomic physicist who can speak about string theory and the like. So, I'm really not giving you an answer. Okay, let's go with that. I'm going to go
Thank
with
you, sir.
I don't know. I pass. Okay. Sorry, Tutu. Okay. Uh, not a good answer. I give myself a 0 on that answer. Uh, so let's move on. India, because it's now getting later. And India is an astrophysicist PhD candidate and a NASA researcher. So, India, you not only are you a PhD candidate, but you're also qualified to answer questions in this room.
No,
For
no,
example,
no, 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 no.
no, no. Can you answer this question? Can you answer why does massless particles move at the speed of light?
Um, why do massless particles move at the speed of light? I can't answer that question. I focus on solar physics.
Okay, that's fine. Listen, uh, uh, the interesting thing I learned about astrophysicists is that they only know what they know,
Right.
and that and see the thing about me is that uh, I don't have to earn a living doing research, so I'm free to actually know everything know a little about a lot, and you have to learn a lot about a little. Uh, so, I never wanted to do that. Uh, so you're studying full of solar physics. What do you study in solar physics?
Well, actually, that's the question that I wanted to
Okay.
ask you. What I was going to ask you what type of research that you're doing and what type of tools that you're using, or if you if you code or anything. But you just said that you didn't. But
I
what I'm
didn't.
trying.
I didn't, and I never did. Once I realized that you had to do research when you got a PhD, I said, "What? I didn't know you had to do that." Uh, it was like a news to me, and I realized that I didn't want to do research.
Yeah,
So I never did it.
it's tough, but what I'm actually trying to do is I'm trying to um like solar physicists now we going from IDL to Python, and what I want to do for my I'm a coder.
Yeah.
I code in 10 different languages.
Uh-huh.
I have an app on the App Store. I did it all by myself. So what I'm trying to do is I'm trying to take all of the open source Python scripts that we have for solar physics, and I'm trying to create a like a software system where instead of you actually having to manually do the code yourself, you can just click buttons, do drop down menus, search bars, that type of stuff. So my question was, what type of research do you conduct, and what type of programming do you use? But you said that you don't do research, and you're a very smart
Right.
person for not choosing to do research.
Can I ask you uh, 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 what the physics that you have tattooed on your chest? What is the physics? I've always envied people who went ahead and did that. I met a woman once who had uh, not Maxwell's equations, but the quantum mechanics, Schrodinger's equations, tattooed on her chest. What equation is that?
Actually, this is a math equation on my chest. I actually started in math, so I have a bachelor's in math. I have a master's in math. I started teaching college math when I was 26. So what you actually see across my chest is Raymond's sum from calculus 2. It's just a definition of a definite integral. And I plan on getting Schrodinger's equation tattooed on the right side of my neck. But yeah, it's just calculus 2 that's tattooed across my chest.
It looked familiar. It looked very familiar. It looked like calculus. Looked like calculus 1 actually to me.
Well, it really depends on the institution because in some institutions they'll teach Raymond sum at the end of Calc 1, and at some they'll teach it at the beginning of Calc 2, but it's definitely within the first and second sequence. Well, it's three, but it's in between the first and second Calc.
Yeah, I had an experience. I met. Uh, don't ever, I'm going to tell you something in the room. Nobody tell anybody else. Okay. I was in Burning Man, and which is a place I'd recommend totally for everybody in the world who's cool. And So I was at Burning Man, and at Burning Man is a gifting economy, and they give you stuff for free. And so I was walking down the street one day, and this woman, nude from the waist up, uh, had Schrodinger's equations on tattooed on her back, and she engaged me, and she gave me a bottle of scotch, and that's what she was giving everybody who was walking down the street, drinks, and we talked quantum mechanics the next 3 hours, uh, and I was trying definitely not to look at her boobs, uh, trying to concentrate on the quantum mechanics, but it was very hard. I That's just a story I'm thrilled and embarrassed to tell. Um, I definitely think it's courageous to tattoo equations on your body. I definitely think not on, but and remember, keep your clothes on. Okay, so, uh, but Jack, don't. He went away. Okay, I hope I didn't insult anybody, by the way, because that could have been sexist. Uh, but nevertheless, I do totally appreciate what you're doing, and I would love to know more about what you've just said. But I think it's going to be hard to talk about in the room since the room is coming closer to the end. Uh, India, did I insult you by any chance? What I said?
No, not at all. It wasn't insulting.
Okay,
Well, hopefully everybody is an
okay,
adult, and it was just something that actually happened. It wasn't
yeah,
insulting at all.
okay,
I mean, I have a huge tattoo across my chest. I expect for people to look there. So,
okay, okay, good, good. I really would love to know more about your coding because I spent most of my life as a coder. So I definitely appreciate that. Uh, and but I never wrote Python because that came after my time.
what languages
Uh,
do you know?
well, uh, uh, Fortran,
I knew you was
uh,
gonna say Fortran. I knew you was gonna say Fortran.
right? And there's PL1, and there's various flavors of BASIC, and C plus and C plus plus, and uh, and a thing called Focus, and uh, I forget. And then there's uh, Visual Basic, but that's a flavor of Basic. Uh, those are the ones that I remember most. Uh, but there was one I tried to learn most recently. It was not Python. It was another one of those new languages that you use in astronomy. But it wasn't Python.
Sorry,
It was
what is a C plus?
what is C plus?
Is that your grade? No, I'm joking. Sorry. I
No,
couldn't.
no, C plus is
Wah,
just
wah.
C plus
It's
is C plus is well, it's C plus plus these days, and it's just one of those languages that are very very primitive in some ways, uh, and but in the case of C plus plus, it's object based.
Yeah, I don't. I'm not sure if there is a C plus. I've heard of C and C plus plus. I was joking. Sorry. I
I
apologize.
know you were. I know you were. No, these are amazing things. I mean, I love programming. I think the programming is more fun than anything because uh, why is it more fun than anything? See, research is annoying because you never get it right, but programming you get it right 10 times a day, or at least wrong 10 times a day, which means you get feedback, which means you can keep working at it long into the night and have a really positive, or if you will, negative, but definitely feedback loop experience. And that makes it a wonderful thing to do. I totally recommend it. It's mental masturbation at its best, you know. And I've enjoyed my entire career in it. So I like if India, if that's what you're doing, you know, programming, I know you're having a lot of fun.
well, that's what I'm hoping I can get approved for, so that I can finish my PhD because I'm going into year 5 in August, and I'm tired and I'm ready to move on because I want to build video games for a living.
Well,
Um,
let me tell you, I got a PhD. Best thing I ever did. Okay, never did a bit of research. Okay, never did a bit of research. But everywhere I walked down the street and I said I have a PhD. People said, "Thank you very much. You're hired."
well,
It
that's
didn't
good to
make it.
know.
I didn't have to take the interview. So if you can manage to get your PhD, you'll save yourself a lot of interview time. Uh, it's the best thing you could possibly do for yourself. Uh, it burned me out. It did. Uh, I barely made it through it. So if you can, do it, but otherwise don't. Anyway, so uh, so next, moving on, India, I'd love to talk to you. Uh, uh, so moving on, Keisha, um, what's your story tonight?
May I ask a question before? Because
Oh,
I
yes,
guess
Setu, I think you were next. Sorry.
yeah, it's all
Yeah.
right. Hello there. So I've just got one question regarding the the gravitrons actually. So as you were discussing with Joel, I've actually he covered pretty much most of it. So basically last year we had Kip Thorne, Dr. Kip Thorne. You might have heard about him. He's a Nobel
Kip
laureate.
Thorne, yeah.
Yeah. So we had a guest lecture at our university. So ever since then, I've been interested in the gravitational aspects of the astrophysics and astronomy. So I've got this question. So like, let's say gravitrons, like if gravitrons exist, and they must be massless since gravitational waves themselves travel at speed of light, right? So so what I am trying to understand is that these gravitrons should be universal as
Right.
long as there's mass, as as long as there's mass in the universe, right? Because gravitational waves are everywhere, right?
Right. Sure. They're there. They're out there. We've seen them. They don't go away.
Yeah. So what I'm trying to understand is that how how do they actually interact with the photons? Because if you see at quantum level, like when you like gravitrons, right? So
Let me stop you. I don't know. Uh, gravitons and photons are entirely independent phenomena. They don't have anything to do with one another. The only time they meet is when we discuss how we can observe the universe using both of those phenomena. They don't interact with one another. Of course they do, because because they're both part of physics. But to try to talk about them in the same breath, not in this room. Uh, not, I don't know what you're talking about. I can't answer that. So let me just stop you there. Okay? Can I do that? Because I want to move on, because we're gonna end the room in about 15 minutes. So that was my short answer. And if you can sit with that, I'd like to move on. Can we do
yeah,
that?
that's not a problem at all. Yeah, you actually pretty much covered when you were answering Joel's question. Really,
Okay,
just
good.
wanted to ask this. Yeah, it's no
Yeah.
worries. Thank you.
Uh, uh, right, because these are interesting but hard questions. Uh, so, Keisha, uh, uh, what is your story tonight? You are binging on Neil deGrasse Tyson's books and talks. Yes. Uh, good.
Yeah.
So, you have one of those questions? Something you read in one of his books, perhaps?
When I was reading about astrophysics written by Neil deGrasse